Hi, I'm Rich Booman. I'm a design engineer here at Tektronix, and today we're going to be using the Tektronix IsoVu measurement system to be making a measurement that was previously impossible. The measurement we're making is high side and low side VGS measurements on a half-bridge switching circuit, which uses two eGaN FETs as the switches. So here's a simplified schematic of the measurement that we're going to be making today. This is a half-bridge configuration showing a high side and a low side FET and a gate driver. The measurements that we're looking at are the high side gate to source voltage and the low side gate source voltage. We also have a single-ended probe that's looking at the switch node by itself, reference to ground. Okay, so here's an example of ideally what we expect these waveforms to look like in this kind of half-bridge configuration. You can see the high side FET turns on, and the source voltage, the switch node, turns on at the same time. Subsequently, the high side gate turns off, there's a dead time, and then the low side gate turns on and pulls the switch node down. So here's the reference design that we're looking at. We have a test point that we've added to the board for our Tektronix IsoVu measurement system. This one is connected to the high side gate source node. We have another one connected to the low side gate source. We have a third probe, which is the passive probe that's connected to the drain, looking at the switch node. We've also added a current loop here if we want to measure the current into the load. So looking at the oscilloscope screen, we can see the high side VGS voltage is the yellow trace here. The light blue trace is the low side VGS, and the magenta trace is the switch node. Now we can zoom in on the high side turn on, and you can see the charging characteristics of the high side gate node. You can see the low side gate node has got some ringing due to parasitic coupling between the low side gate, the low side FET, and the switch node. Right now our power supply is running at 150 volts, and if we didn't have excellent common mode rejection, then this 150 volts would be coupling into both of these measurements and would be obscuring the true differential measurement that we're getting with the IsoVu. IsoVu has a 1,000,000 to 1 common mode rejection ratio at these frequencies, which is enabling us to make a true differential measurement. So now we're looking at the high side FET turnoff characteristics. Again, the yellow trace is the high side VGS. You can see it start to turn off here. You can see the low side FET turning on here. You can see the charging characteristics of the low side gate. You can see the dead time between the high side gate turn off and the low side gate turn on. And you can also see the parasitic coupling from the switch node into both of the gates, and the ringing caused by the parasitic coupling onto the high side gate node, which is especially concerning because if this ringing is large enough to turn the device back on, you can get a short between the power supply and ground, and you can damage or destroy one or both of these devices. And this is the kind of measurement that is impossible to make today because of the inadequate common mode rejection of most of the devices that are out there. Because we have 1,000,000 to 1 common mode rejection, we can be confident that these are the true differential measurements that we're looking at. This is the true differential high side gate source voltage that's riding on top of this 150 volt switch node. To make these kind of measurements possible, you need a measurement system that combines high common mode rejection ratio, high common mode voltage, and sufficient bandwidth. With its complete galvanic isolation, the Tech IsoVu system has 1,000,000 to 1 common mode rejection ratio at 100 megahertz. It has gigahertz of bandwidth and 2,000 volt common mode rating. The combination of these specifications is what makes these kind of measurements possible with the Tektronix IsoVu measurement system.
Find out more at Vicom's website.